So conversions, what you need is a way to connect one unit to another. Now, we have some conversions that we're familiar with, the Imperial system that we're trying sort of, but not really trying to get rid of. Like we know that there's 12 inches in 1 foot. So this is an equivalency. They're the same thing. They measure the same length. We know that there are 100 centimeters in 1 meter. Anybody remember how many centimeters in an inch? You may have come across this before. It's around 2.5. Yeah. 2.54 is a little bit closer. I bicycle a lot, and typically when people bicycle, they have these little bicycle computers that are phones, measure how far they went and what their speed was, things like that. And we're used to driving in miles per hour, and most bicycle computers do the same thing. They measure miles per hour. I went to Portugal last year, and all the speed limit signs are not in miles per hour. What do you think they're in? Closer? Kilometers. There you go. Yeah, they're in kilometers, right? And the speed limit's in kilometers per hour. Okay. And I rented a bike when I was there, and I biked around Portugal, and the bike had a little computer on it. And guess what it gave me information on? Oh, how many kilometers I rode, how many kilometers per hour I rode. So when I was over there, I got used to how to translate. And so the fact that stuck in my head that I remember is that there are 1.609 kilometers in 1 mile. Related back to that, 1.609 kilometers is how many meters? Think back about the kilo we talked about before. 1,609. Yeah, it's 1,000 times kilometer versus meter. And so it'd be 1,609 meters is 1 mile. And I use these two all the time when I need to translate to somebody that does things in kilometers per hour versus somebody that does things in miles per hour. So I have some Canadian biker friends. When I was in Portugal, I made some Portuguese biker friends. And when they share their rides, it's in kilometers per hour. And when I share mine, it's miles per hour. Until recently, I decided, I guess I should do what everyone else is doing. And now my bike computer is in kilometers per hour. Now, the downside of that is all my friends say, well, what was your speed? What was our distance? I say, oh, we did 20 kilometers today. And they pause for a minute and try to think, shit, how much is that? And then I give them one of these tips. So you can look it up, right? But it's about time we kind of join the rest of the world there. So thing about conversions is having these factors written down somewhere is how the conversions happen. And the way I recommend this be taught if you have to teach it, which this is kind of slipping out of the curriculum because we have calculators everywhere, is we usually use conversion fractions. So I'm just going to do a couple of examples of using conversion fractions. And we're going to move on to some area stuff. So what a conversion fraction is, sometimes I need to convert, and I can't remember, shit, do I multiply or do I divide by the number in the conversion? And the conversion fraction helps iron that out. So for example, I mentioned earlier, I went for a ride the other day, and my friend said, how far did your computer say we went? And I said we went about 20 kilometers. Now that's not what he wanted to hear because he's used to measuring things in miles. So I want to convert that to miles for him. Well, I happen to know this factor that there's 1.609 kilometers in a mile. And every once in a while, like I get really brain dead. I'm like, oh shit, is it 1.6 kilometers in a mile or 1.6 miles in a kilometer? And I do recall from younger that a mile is a longer thing than a kilometer. And if I remember that, a mile is longer, then I must need more kilometers to make a mile. So it's got to be the 1.69 kilometers isn't a mile. So sometimes I have to think to remember which is which one's the bigger one. And that can help sometimes. Next, if you can't remember, so once you get the fact down, so I'm establishing this is the fact that I need, if I can't remember whether I multiply or divide, I make a fraction. The way the fraction works is you're going to multiply by a fraction. and stuff has to cancel for this to work. Well, if we think about fractions and multiplication, the only time things cancel is if they're in opposite position. Remember, like numerator, denominator? So the 20 kilometers is essentially 20 kilometers over 1. So for the kilometer part to go away, it would have to be in the denominator of the fraction I multiply by. That makes sense? To cancel it? Well, kilometers are on the bottom, and I want miles, then miles has to go on the top. And then I happen to remember the fact that there's 1.609 kilometers in a mile. So the only real point of these conversion fractions is to remember whether you multiply or divide by the conversion equivalency you were given. So this tells me here that if I want kilometers to go and miles to stay, 1 mile there, then this means I'm going to have to divide because it's in the denominator. So when I whip out my calculator, I say, okay, let's take 20 and divide it by 1.609. And the result has to be miles because I just canceled kilometers. And oops, MI for miles. So a couple of important things. One, in order to make conversions happen, we need to know a relationship between the units that we're working with. Two, in order to figure out whether to multiply or divide, a conversion fraction can help identify whether you should multiply or divide. Because if you do the wrong thing, you're going to totally mess it up. Okay, so let's whip out a calculator and see what we get, and then we'll check with Google. Desmos, it's my favorite calculator these days. And I'm going to take my 20 and I want to divide it by 1.609. And according to my Desmos calculator, that means I went about 12 points. And then the question is how many decimal points, the places to keep. And it's like, it just depends. So I'm going to go with 2 just for fun here because there's a couple zeros after that. So I would say it's about 12.43. Now, I think conversions like this are going to be minimized in curriculum by the time you guys are teaching. They already are being minimized a little bit for a couple of reasons. One, a lot of classrooms have some kind of calculators in them. And even more classrooms have tablets and computers in them, even for kids as young as first and second grade. Okay, pro and con. Sometimes it's a good thing, sometimes it's not. I think most kids need less screen time, but this is the crazy world we live in. So often, I don't know about you guys, when I need to convert, I just ask Google to do it for me, right? I'm going to write something like 20 kilometers, 2 miles, and Google's already guessing what I want to do before I even finish it, which is a little bit exciting and scary. And Google gives a similar but different answer. It says it's more like 12.4274. And then look at what it says underneath. For an approximate result, divide the length value by 1.609. Isn't that what we did? Yeah, and sometimes Google does exactly what I would have done. Other times it does something different, just because it was programmed with a different default conversion factor. Just depends. So what's the point? Computers are doing our conversions for us. By the time you guys get to, say, teaching, conversions might not be in the curriculum anymore. I'm not sure if that's a good thing or a bad thing.
Like chemistry all over.
Oh yeah, chemistry, you got to do a shitload of conversions to make things work out right. Yeah, for sure. Okay. So again, 2 main points here. One, for conversions to happen, you need some kind of relationship between the 2 kinds of units you're converting to. And sometimes it might be a direct one, but sometimes you might need multiple steps to get there. Okay. And then the other thing is conversion fractions can help you decide whether to multiply or divide if you're not sure. Okay. Let's do one more and then I'm going to move on. Every once in a while, something happens where I measure something and then I do a calculation based on it, and then I get some number I'm not sure how to deal with. So let's suppose we did a calculation playing around with centimeters, and we got something like 685 centimeters. Actually, let's make it bigger. Let's make it 7,685 centimeters. That's a pretty big number. in centimeters. Centimeters is a small thing. So then I have to decide, okay, I got to convert this to a friend who uses the imperial system. Do I convert it to inches, feet, or miles, which is the best one? Well, that's going to be a lot of inches, right? So maybe I want to convert it to feet. But it could be that's going to be a ton of feet too, and maybe I want to convert it to miles. I don't know. Let's try feet and see. So let's say I want to convert this to feet. And there's going to be some homework problems like this. And it could be you just go to Google and say, hey, convert this to feet for me. And Google will do a one-step problem for you. We'll do that next for comparison. But here's how I would do it without having a conversion calculator like Google. First thing I would do is say, well, I remember centimeters to inches, right? Earlier, we noted that there's about 2.5 or 2.54 centimeters in an inch. Is that an exact relationship? No, it's really approximate, not completely exact. So we're just going to put a wavy sign there. So from the 7,685 centimeters, if you're not sure whether to multiply or divide, then make your conversion fraction. Centimeters is currently in the numerator of an invisible denominator there. So that means I should put centimeters in the bottom to convert and inches in the top because I know a relationship between centimeters and inches. That means the 2.54 has to go in the bottom. And if it's in the bottom, what does that mean about the calculation I have to make? Is it a multiplication or a division? It's a division because it's in the denominator, right? Fraction bar means divide. Now, that gets me one step closer to where I want to be. I'm at inches, but I really want feet. And hopefully we remember that there are 12 inches in a foot. And so I can just tack on another conversion fraction to get rid of inches. Always remember the unit has to go in the opposite place. And there's 12 inches in 1 foot. So what this tells me is starting with 7,685, I should first divide by 254, or 2.54, excuse me, and then divide by 12, because they're both denominators. And that will give me an answer in feet, because that's the only thing left. So we'll do two things. We'll plug that into a calculator, see what we get, and then we'll just ask Google, see what Google says. First, Desmos. And Desmos is a little weird because it stacks fractions, so it looks a little different. 7, 6, what was it, 8, 5? Yeah. There we go. Divided by first 2.54. And then to get the division right, you have to arrow out to the side if you're using Desmos, and then do division again by the 12. And so I get 252-ish feet. And do I need that extra decimal? No, let's write it in just for fun. With 2 decimal places, I get 13, so 252.13. So this is about 252.13 feet. What does the 0.13 mean? 0.13 feet. About 13% of a foot, right? 0.13 would be 13%. Okay, it's not inches. So that's one thing we have to be careful in the imperial system. Decimal values are fractions of that unit we're starting with. And that's a common confusion in the imperial system. If we had written it as, say, like, we could call it 252.1, couldn't we? That would be an okay rounding here. And the 0.1 isn't 1 inch, it's 1/10 of a foot, right? Which is a little different than an inch. It's kind of weird, but that's what it is. Let's ask Desmos. Google. What does Google think? See if we get similar answers. Type a Google search to do this into your phone or computer if you have one. Will it give us a similar answer? Good. Might not give us the same answer.
Five, 9 inches. And, 252.
So I'm starting with the 7,685 centimeters, and I just asked it to translate to feet. And Google says 252.1325, similar to what Desmos said. Oh, that's almost exactly the same as what Desmos said. So sometimes it's the same as what I calculate, sometimes it's not. You got something different? What did you get?
About the wording, so I said how many feet are in 7,685 centimeters. I said,
Well, if you don't word it right, Google might do something different for you.
because that just says 252 feet and 1.591 inches.
Oh, it made a fraction of an inch. It turned the fraction of feet into inches. Okay, that's interesting. Yeah, that's a little bit.
But it
different.
also gives like below it. You can look at it.
And then depending on the type of the end. Oh, the decimal version too. Yeah, and then it gives us a tip to divide by 30.48. Where the hell did it get that? Almost.
Or by,
Yeah, let's look back here. So again, it gave a tip. Let me copy this into the screen and blow it up a little bit. So Google automatically did this for me here. And then underneath it says divide the length by 30.48. And if you look at the first way I wrote it in green, it's lumping these two things together. And when you multiply fractions, what happens to the numerators and denominators? Well, they get multiplied together. So what Google did is it took the 2.54 times 12, and that's where it got the 30.48. So it just simplified the procedure a little bit to make that happen. Bella's gave it turned the 0.1325 into inches for us. So let's take a look at that. We've done stuff like that before in class, but it's been a while. So let's see, I need a new page. All right, so we started, whoa, and is stuck in highlighter mode. Stop. Okay, weird. Okay, we started with the 7,685 centimeters, and we wanted to convert that into feet. And some of us plugging it into Google got the same feet point something answer, but some of us also got feet in inches. So what if instead I wanted it in feet and inches? How do I go about doing that? So kind of the same thing I did before. I'm going to take that 7,685 centimeters. And this time I'm just going to take Google's advice. And Google's advice was to divide that by 30.48. And that would convert the centimeters into feet. And if we look to see what happens there in the calculator, so just, oops, which does most, there we go. If I take the 7,685 and I divide it by 30.48, right, it gives me, oh, I missed my decimal point. There we go. I get that 252.13, blah, 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 the fractional part. So here's the way to think about how to deal with the inches. So again, this gives me about 252 points. And I'm just going to stick with the 1.3 for now and not worry about the rest of it. And that is feet. And this right here is a fraction of a foot. So I'm just going to break this up into two parts. So that's 252 feet and 0.13 feet. How many feet are an inch? Oh, other way around. How many inches in a foot? There we go. 12, right? So to clean up this fraction of a foot thing, we would just deal with, to get rid of feet, we would multiply in inches, 12 inches in 1 foot. So the feet will go if I multiply just that by 12. I'll check that on my calculator. 0.13 is the decimal I'm keeping. If I multiply that 12, that should turn it into inches, and I get about 1.5 inches, a little over 1.5 inches. So that gives me about 1.56 inches. Oops. So 7,685 centimeters is about the same as 252 feet and about 1.5 inches. So important thing here is when we're playing with imperial units that aren't based on multiples of 10 or factors of 10, then dealing with a decimal is a little trickier. Right? It's not the next unit down in the imperial system. But in the metric system, it is the next unit down, which is kind of nice. All right, I lied. There's going to be one more example, and then we're going to move on. Take, for example, 2.5 centimeters. What's the next smallest unit after centimeter? Anybody remember? Millimeter would be next. So this would be 2 centimeters. And how many millimeters? 2.5 centimeters is 2 centimeters and blank millimeters. Just 5. That's it. No conversion. It's just, it is what it is. Because the metric's always based on powers of 10. All right. Last one, and then area. Suppose we had 1.74 meters. That would be the same as 1 meter and blank centimeters. What was that? 74, yeah, because it's centimeter is 2 units away from metric, from a meter, so it would be 2 decimal places away, so it'd be 74 centimeters. Yeah, so all you have to do is think about the relative positions of things like millimeter, centimeter, decimeter, meter, and so on, and it's easy to shift from one to the other, and even mix them together isn't that bad. Whereas in our imperial system, it's a total pain in the butt. Especially when you start getting into liquid stuff, when you have cups, pints, quarts, gallons, ounces, and they don't relate to weight ounces, which is a totally different thing. Okay, so that's enough with linear stuff for now.